Look at your hand right now. Go ahead, really look at it. That solid, undeniable piece of reality you're staring at? It might not have existed a second ago. Not in the way you think it did. And I'm not being poetic or philosophical here. I'm talking about hard, experimental physics that has shaken the foundations of reality itself. In 1978, a physicist named John Wheeler proposed something so disturbing that even Einstein would have recoiled. He suggested that the act of observation doesn't just reveal reality, it actually creates it retroactively, backward in time. The photons hitting your eyes right now aren't just bouncing off your hand to show you what's there. They might be collapsing the wave function of matter itself, forcing reality to choose what your hand actually was for the past several seconds, minutes, or even billions of years. Here's the kicker that's going to haunt you. Experiments have confirmed this isn't just theory. In 2007, researchers at the Australian National University conducted Wheeler's delayed choice experiment with actual photons that had traveled for millions of years. The decision made by observers in the laboratory appeared to determine the path those photons took millions of years in the past. Reality, it seems, can be edited retroactively by observation. So when I ask, does matter exist without light observing it? I'm not asking a philosophical question. I'm asking whether the entire universe, including your body, your memories, and everything you've ever known, only crystallized into definite existence the moment light carried information about it to an observer. And the answer quantum mechanics gives us is far stranger than any fiction. Before we dive deeper into this reality-shattering rabbit hole, do me a favor. Hit that subscribe button and smash the like button, because you're going to want to come back to this video multiple times to fully wrap your head around what we're about to discuss. And drop a comment telling me what country you're watching from and what time it is where you are. I'm genuinely curious how many people around the world are having their reality questioned at this very moment. Now, let's start by understanding what we mean by matter and observation, because these words don't mean what you think they mean in the quantum world. When you learned about atoms in school, you probably got the classic model. A tiny nucleus with electrons orbiting around it, like planets around the sun. Solid little balls of reality, just really, really small. That model is completely, fundamentally wrong. Not approximately wrong. Not oversimplified. Wrong in a way that misrepresents the actual nature of reality. Matter, at the quantum level, doesn't exist as particles in definite locations until something interacts with it. Before measurement, before observation, before any interaction with light or any other force carrier, quantum objects exist in what we call superposition, a state where they're simultaneously in all possible locations, all possible states, all possible configurations at once. Think of it like this. Imagine you have a coin spinning in the air. While it's spinning, it's neither heads nor tails. It's both and neither simultaneously. Only when it lands, when something interacts with it and forces it to choose, does it become definitely heads or definitely tails. Quantum particles are like that coin, except they never actually land until something observes them. And here's the truly bizarre part. They're not just spinning coins. They're coins that exist as both heads and tails in all locations across the entire table, simultaneously until you look. The double-slit experiment, first performed by Thomas Young in 1801 and refined countless times since, demonstrates this in a way that still makes physicists uncomfortable today. When you fire electrons, photons, or even entire molecules at a barrier with two slits, something impossible happens. If you don't observe which slit the particle goes through, it goes through both slits simultaneously, interfering with itself like a wave and creating an interference pattern on a screen behind the slits. But the moment you put a detector at the slits to observe which path the particle takes, the interference pattern disappears. The particle chooses a single path. It's as if the universe only makes up its mind about which path was taken when forced to show its cards by observation. Now here's where it gets personal and weird. What counts as observation? Do you need a conscious human watching? No. Any interaction with the environment that creates an information record counts. A photon bouncing off the particle counts. The particle interacting with air molecules counts. Anything that could theoretically tell you where the particle is counts. But here's the question that should be making your brain itch. What about before there were any observers in the universe? What about the 13.8 billion years before conscious beings evolved? Did matter exist then? The Copenhagen interpretation of quantum mechanics, developed primarily by Niels Bohr and Werner Heisenberg in the 1920s, suggests something radical. The wave function, this mathematical description of all possible states a quantum system could be in, doesn't represent incomplete knowledge about a definite reality. It is the reality. Until measurement, particles don't have definite properties. They're literally spread out across all possibilities. Bohr would argue that asking, "Did matter exist before observation?" is like asking, "What does blue smell like?" It's a category error, applying classical concepts to a quantum realm where they don't apply. Matter, as we think of it, solid objects with definite positions and properties, only exists in relationship to observation. But here's what will blow your mind. Light plays a special role in this cosmic game of hide and seek with reality. Light, electromagnetic radiation, photons, whatever you want to call it, is the universe's primary information carrier. It's how observations happen. It's how quantum systems interact and collapse from superposition into definite states. In a completely dark room, sealed from all electromagnetic radiation, quantum objects would exist in pure superposition, never forced to choose definite states. But we don't live in such a universe. The Big Bang filled space with photons, the cosmic microwave background radiation that permeates everything. Stars pump out photons continuously. Your body emits infrared radiation. Light is everywhere, constantly probing, constantly interacting, constantly collapsing wave functions. So in a very real sense, the universe is perpetually observing itself through light. Matter doesn't exist without light observing it, because light is the observation mechanism of reality itself. Let me give you another analogy. Think of reality as a massive multiplayer video game, but one where the graphics only render when a player can see them. When you turn around in such a game, the scenery behind you doesn't exist in detailed form. It's just saved as mathematical probabilities to save processing power. Only when you look, when light carries information from objects to your eyes, does the universe bother to render the specific, definite version of reality. Quantum mechanics suggests something eerily similar might be true about our universe. Not that we're in a simulation, necessarily, but that reality operates on an as-needed basis, only crystallizing into definite states when observation forces it to choose. Now you might be thinking, okay, but surely the moon is there when nobody looks at it, right? Einstein certainly thought so. He famously asked that very question to challenge the Copenhagen interpretation. Surely, classical objects, macroscopic things like moons and chairs and hands, aren't in quantum superposition. They're made of so many particles constantly interacting that they're always being observed by their environment, right? And you'd be mostly right, but that mostly is doing a lot of heavy lifting. Because here's where things get exponentially weirder, and why the next section is going to fundamentally change how you see reality. The phenomenon we need to understand is called decoherence. It's the process by which quantum systems transition from strange, superposed quantum states to classical, definite states through interaction with their environment. And light is the primary mechanism of decoherence. In the late 1980s and early 1990s, physicists like Wojciech Zurek developed the theory of quantum decoherence in detail. What they found was that large objects aren't exempt from quantum weirdness because they have some special classical property. They behave classically because they're constantly being bombarded by photons from their environment, constantly being measured, constantly having their quantum coherence destroyed by interaction with light and other particles. Here's the staggering implication. If you could perfectly isolate a large object from all interaction, including all electromagnetic radiation, it would start behaving quantum mechanically. It would exist in superposition. The boundary between quantum and classical isn't about size, it's about isolation from observation. In 2019, researchers in Vienna demonstrated quantum interference with molecules containing up to 2,000 atoms. These aren't subatomic particles. These are complex molecular structures, and they showed quantum behavior existing in superposition, going through multiple paths simultaneously because they were isolated enough from environmental decoherence. The implications are staggering. In principle, there's no size limit to quantum behavior. A cat could be in superposition. A human could be in superposition. An entire planet could be in superposition. If you could isolate it from all observation, all interaction with light and other particles. But we live in a universe flooded with light. The cosmic microwave background alone ensures that virtually nothing in the cosmos is truly isolated. Photons are constantly pinging everything, forcing the universe to maintain definite states. Light is constantly observing matter, constantly collapsing wave functions, constantly making the universe real. Let me paint an even stranger picture for you. Imagine the early universe, fractions of a second after the Big Bang. Matter and energy were so dense that light couldn't travel freely. Photons would get absorbed and re-emitted almost instantly. The universe was opaque. During this era, before the universe became transparent to light about 380,000 years after the Big Bang, quantum fluctuations in the density of matter existed in superposition. They were simultaneously denser and less dense in all possible configurations. Only when the universe cooled enough for light to travel freely, for photons to decouple from matter and stream through space, did these quantum fluctuations get observed and collapse into definite density variations. Those density variations became the seeds of all structure in the universe. The galaxies, stars, planets, and ultimately, you, exist because light observed quantum fluctuations and forced them to become real 13.8 billion years ago. You are quite literally the product of light, observing the universe into definite existence. But here's the question that should be keeping you up at night. Who or what observed the first photons? What collapsed the wave function of light itself? This is where John Wheeler's participatory anthropic principle comes in, and I promise you, this is where your conception of reality is about to completely invert. Wheeler proposed that the universe doesn't just create observers. Observers create the universe, not in a mystical or metaphysical sense, but through the concrete mechanism of quantum mechanics. The act of observation by conscious beings in the present might be collapsing wave functions all the way back to the Big Bang, retroactively creating the history that led to those observers existing. It's a causality loop. The universe creates conditions for observers to evolve, and observers, through the act of observation, retroactively create the definite universe that allowed them to evolve. Reality bootstraps itself into existence. In 2007, this wasn't just philosophy. Physicists at the Australian National University, led by Andrew Truscott, actually performed Wheeler's delayed choice experiment. They sent photons on a journey and made the decision about how to measure them after the photons had already passed the point where they would need to choose their behavior. Classical intuition says the photons must have already chosen whether to behave as particles or waves before the measurement decision was made. But that's not what happened. The photons' behavior depended on the future measurement choice. The present determined the past. They later refined this with a cosmic version. Using photons from distant quasars that had been traveling for billions of years, they showed that measurement choices made today determined the path those photons took billions of years ago, back when Earth didn't even exist. Think about what this means. When you look at light from a distant star, You're not just receiving information about the past. You're potentially collapsing the quantum state of photons, determining retroactively which path they took through space over millions or billions of years. The universe's history isn't written until it's observed. It exists in quantum superposition, as all possible histories simultaneously, until observation collapses it into one definite history. This is the block universe on quantum steroids. Time isn't a river flowing from past to future. It's more like a quantum superposition of all possible pasts, presents, and futures that crystallizes into definite reality only when and where it's observed. Now, I know what you're thinking. This sounds insane. This can't be how reality actually works. Surely there's a more sensible interpretation of quantum mechanics that doesn't require this time-bending, observer-created reality? There are alternative interpretations, and in the next section, I'm going to walk you through them. But I'll warn you, every single interpretation of quantum mechanics requires you to give up something you thought was obviously true about reality. The only question is what you're willing to sacrifice: locality, realism, causality, or uniqueness. Reality demands you choose your poison, and if you think you can stay neutral and keep watching without consequences, well, you're about to find out why that's impossible. But before we dive into that existential crisis, take a moment to like this video if your brain hasn't exploded yet, and drop a comment about which interpretation of quantum mechanics you find least disturbing. I bet I can predict what most of you will choose, and I'll explain why that instinct is exactly what quantum mechanics is trying to tell us about ourselves. The many worlds interpretation, proposed by Hugh Everett III in 1957, offers a radically different take on observation. In this view, wave functions never collapse, ever. When a quantum system reaches a point where it could go one way or another, the universe splits. Both outcomes happen, just in different branches of reality. When you observe a particle that was in superposition, you don't force it to choose a state. Instead, you become entangled with it. One version of you sees it in one state. Another version of you in a parallel universe sees it in another state. Both are equally real. In the many worlds view, matter absolutely exists without light observing it. But the cost here is locality, and in a sense, causality. The pilot wave is non-local. It can instantaneously affect particles anywhere in the universe. When you measure one particle in an entangled pair, the pilot wave instantaneously changes, affecting the other particle no matter how far away it is. Information doesn't travel faster than light, but the wave function does. Reality has instantaneous connections spanning cosmic distances. Also, pilot wave theory is explicitly deterministic. The future is completely determined by the past. Free will, if it exists at all, is an illusion. Every action you've ever taken was predetermined by the exact configuration of particles and pilot waves at the Big Bang. Then there's cubism, quantum Bayesianism, developed by physicists like Christopher Fuchs in the early 2000s. This interpretation says the wave function isn't describing reality at all. It's describing your personal knowledge and expectations about reality. When you observe a quantum system and the wave function collapses, you're not changing reality. You're updating your beliefs. The wave function is in your head, not out there in the world. Different observers can have different wave functions for the same system, and that's okay, because they're just different states of knowledge. In cubism, matter absolutely exists without observation. It just has properties that are, in principle, unknowable until you interact with it. The quantum state isn't a real thing waiting to be discovered. It's a tool for making predictions about your personal experiences. This interpretation preserves a kind of realism, but at the cost of making science subjective. Different observers have different, but equally valid wave functions. There's no objective quantum state of the universe, just as many quantum descriptions as there are observers making predictions. And here's the one that really messes with people. Objective collapse theories, like the GRW, Gerardi-Rimini-Weber theory proposed in 1986. These theories say wave function collapse is a real physical process that happens spontaneously. It's not caused by observation. It's a fundamental feature of nature. In GRW, quantum systems spontaneously collapse to definite states at random intervals. For single particles, this happens incredibly rarely, maybe once every 100 million years. But for large objects made of many particles, the collapse rate is much higher. This is why macroscopic objects seem classical. They're collapsing so frequently that you never catch them in superposition. This interpretation says matter exists without observation, but it's constantly undergoing spontaneous localization, randomly choosing definite states. Observation works because it amplifies these spontaneous collapses through interaction with many particles in measuring devices. The cost? You have to modify quantum mechanics itself. You have to add new terms to the equations that have no other justification except to make wave functions collapse. And despite decades of effort, no one has experimentally detected these spontaneous collapses or the subtle energy non-conservation they would cause. So which interpretation is correct? Here's the truth that physicists hate admitting. We don't know. All of these interpretations make identical predictions for any experiment we can currently perform. They're empirically equivalent. Choosing between them isn't a matter of experimental evidence, it's a matter of philosophical preference. But here's what's crucial. In every single interpretation except many worlds and objective collapse, observation plays a fundamental role in defining reality. Whether it's collapsing wave functions, updating knowledge, or disturbing pilot waves, the act of light carrying information about a system is essential to the reality we experience. Matter might exist in some sense without observation, but the matter we can talk about, measure, interact with, the matter that makes up the world we experience, is fundamentally entangled with observation itself. And light, electromagnetic radiation, is the primary observation mechanism of the universe. Without photons, without light constantly interacting with matter, quantum coherence would persist far longer. The universe would be far more quantum, far less classical, far less definite. So does matter exist without light observing it? The answer depends on what you mean by exist, and that's not a cop-out. That's the genuine, profound truth quantum mechanics forces us to confront. Existence itself is not what we thought it was. Now let me show you why this isn't just abstract physics. In the next section, we're going to talk about how this plays out in the most familiar substance in your life, the atoms that make up your body. And what you're about to learn will change how you feel about your own physical existence. Your body is made of atoms: carbon, hydrogen, oxygen, nitrogen, and trace elements. About 7 octillion atoms, if we're counting. Each one is a quantum system. Each one, isolated from observation, would exist in superposition. But you're not in superposition. You're reading this, having a definite experience, existing in a definite state. Why? Decoherence, as we discussed, is part of the answer. Your atoms are constantly interacting with each other, with photons from your environment, with thermal radiation. These interactions destroy quantum coherence incredibly quickly, in femtoseconds for most biological molecules. But here's the eerie part. The decoherence that makes you classical, that gives you a definite body and definite experiences, is overwhelmingly mediated by light. Photons are constantly scattering off your body. Infrared radiation from your thermal energy is constantly being emitted and absorbed. Visible light from your environment is bouncing off your skin, entering your eyes. Your body, as a definite classical object, is constantly being held in that definite state by its interaction with light. You are being observed into existence trillions of times per second by electromagnetic radiation. Think about that. The solidity of your flesh, the definiteness of your position in space, your persistence as a classical object, all of this depends on continuous observation by light. If you could somehow shield yourself from all electromagnetic radiation, all thermal photons, all light of any kind, you would start to decohere more slowly. Your quantum nature would become more apparent. Now, I'm not saying you'd go into macroscopic superposition immediately. The interactions between atoms in your body would still cause decoherence, but the rate would slow dramatically. And in principle, if you could eliminate all interaction, including between your own atoms, you would cease to exist as a definite object. You'd spread out into a quantum mist of all possible configurations. You are held together, made real by constant observation. This isn't metaphor. This isn't poetry. This is what quantum mechanics is telling us about the relationship between matter and observation. And here's where it gets personal and philosophical. Your brain, your thoughts, your consciousness are all patterns of neural activity. They're electrochemical signals, patterns of atoms and electrons in specific configurations. These patterns are maintained by constant interaction, constant observation, constant decoherence induced by the electromagnetic fields generated by your neurons themselves. Some physicists and philosophers, like Roger Penrose and Stuart Hameroff, have proposed that consciousness itself might be related to quantum processes in microtubules within neurons. The idea is controversial and not widely accepted, but the core insight is profound. If consciousness has any quantum component, then the act of being conscious might be intimately related to the act of observation that collapses quantum states. You might not just be observing reality into existence. Your consciousness might be reality observing itself into existence. This is Wheeler's participatory anthropic principle at its most profound. The universe creates conditions for observers to emerge, and observers, through consciousness and observation, create the definite universe. It's a self-creating loop. Now, I want you to think about something that's going to sound crazy. What if the reason the universe seems finely tuned for life is precisely because life is necessary to observe the universe into definite existence? What if the constants of nature, the strength of fundamental forces, the mass of particles, all of these things that seem improbably perfect for allowing complex structures like stars and planets and life to exist, are the way they are because only universes with those properties can have observers to collapse their wave functions. This is the strong anthropic principle with a quantum twist. The universe isn't just compatible with our existence as observers. Our existence as observers might be required to give the universe definite properties in the first place. Before you dismiss this as too weird to be true, consider this. The Wheeler delayed choice experiments show that present observations can determine past states. If observation can work backward in time, then observers existing now could retroactively determine the properties of the universe at the Big Bang, ensuring those properties were compatible with the eventual evolution of observers. It's a self-consistent causal loop. The universe has properties that allow observers to exist because observers exist and retroactively collapse the universe into having those properties. This isn't proven, of course. This is highly speculative, riding the edge of physics and philosophy. But it's not inconsistent with quantum mechanics. It's one possible implication of taking quantum mechanics seriously at cosmic scales. And here's the part that should give you existential chills. If this is true, then you, personally, by observing the universe, by collapsing wave functions through your interactions with light and matter, are participating in the creation of reality. Not just your subjective experience of reality, but reality itself. Every time light enters your eyes, every time a photon bounces off your retina and gets absorbed, triggering a neural signal, you're collapsing quantum states. You're taking a universe of possibilities and actualizing one specific outcome. You're creating reality. Multiply this by 8 billion humans, each one constantly observing, constantly interacting with light, constantly collapsing wave functions. Add in all the other observers, animals with visual systems, organisms with light-sensitive proteins, even plants responding to sunlight. The biosphere is a massive, distributed observation apparatus, constantly pinning down reality, constantly forcing the universe to be definite. And before the biosphere, observation was still happening, but through purely physical processes. Photons interacting with matter, creating information, destroying quantum coherence. The universe was observing itself through the constant interaction of light with matter long before conscious observers emerged. But conscious observers might play a special role. We can perform controlled measurements. We can set up experiments that probe specific quantum properties. We can choose what to observe. And if observation really does work backward in time through Wheeler-style delayed choice mechanisms, then our choices about what to observe might be shaping the history of the universe. This is getting deep, I know. Your brain might be hurting. That's good. That means you're actually grappling with the implications. Take a breath. Like this video if you're still with me. And comment about whether you think consciousness plays a special role in quantum observation, or if you think it's just physical interaction all the way down. I'm genuinely curious about your intuitions here, because they reveal something about how you conceptualize your place in reality. Let's ground this back in concrete physics for a moment, because I want to show you that this isn't just speculation. There are real, testable predictions and ongoing experiments trying to probe the boundary between quantum and classical, trying to understand exactly what counts as observation and when wave functions collapse. In quantum optics labs around the world, researchers are creating larger and larger quantum superpositions, trying to find the limit where quantum behavior breaks down. In 2010, Aaron O'Connell at UC Santa Barbara created a quantum superposition of a tiny mechanical resonator, a device visible to the naked eye, containing trillions of atoms, vibrating and not vibrating simultaneously. This object was shielded from light as much as possible, cooled to near absolute zero to minimize thermal photons, isolated to prevent decoherence, and it behaved quantum mechanically. It was, in a real sense, in two places at once. But the moment they tried to measure it with light, by bouncing photons off it to see where it was, the superposition collapsed. The light observation forced it to choose a definite state. More recent experiments have created superpositions of increasingly large molecules and even tiny diamonds. The trend is clear. There's no fundamental size limit to quantum behavior. The limit is decoherence, and decoherence is almost entirely caused by interaction with environmental photons and thermal radiation, forms of light. So the answer to, does matter exist without light observing it, in the practical, experimental sense is, matter can exist in quantum superposition, in multiple states or locations simultaneously, but only if it's shielded from light. The moment light interacts with it, the superposition collapses. Matter becomes definite. Light is the arbiter of reality. Now let's talk about entanglement, because this is where the relationship between matter and observation becomes truly non-local and truly weird. Quantum entanglement, described by Einstein as spooky action at a distance, is a phenomenon where two or more particles become correlated in such a way that measuring one instantly affects the other, no matter how far apart they are. Here's a classic example. Create a pair of photons in an entangled state where their polarizations are correlated. Send one photon to a lab on Earth. Send the other to a lab on the Moon. Before you measure either photon, both exist in superposition, simultaneously vertically and horizontally polarized. But when you measure the Earth photon and find it vertically polarized, the Moon photon instantly becomes horizontally polarized. Not is revealed to have been horizontally polarized, becomes horizontally polarized. The collapse of one particle's wave function instantaneously collapses the others. John Bell proved in 1964 that this correlation can't be explained by the particles having predetermined properties from the moment they were created. The correlations are stronger than any local hidden variable theory can account for. When you observe one particle, you genuinely affect the other instantly across arbitrary distances. Alling Aspect and colleagues confirmed this experimentally in the 1980s and countless experiments since have verified it with increasing precision. The 2022 Nobel Prize in Physics went to Aspect, John Clauser, and Anton Zeilinger for their work on entanglement. Here's what this means for our question. When you observe one particle with light, by having a photon interact with it and carry information to a detector, you're not just collapsing that particle's wave function. You're collapsing the wave function of every particle entangled with it, potentially across the entire universe. Observation is non-local. The effect of light observing matter ripples instantly through the web of quantum correlations connecting entangled particles. And here's the truly staggering part. In the early universe, everything was entangled with everything. Before the universe became transparent to light, all particles were in thermal equilibrium, constantly interacting, creating vast networks of entanglement. As the universe expanded and cooled, particles became separated, but their quantum correlations persisted. Right now, particles in your body are potentially entangled with particles billions of light years away. When those distant particles interact with light, when photons from distant stars or galaxies scatter off them, collapsing their wave functions, that collapse might be affecting particles in your body, choosing their states from superposition. You are quantum mechanically connected to the entire observable universe through entanglement. And light, traveling from all directions, constantly observing matter everywhere, is constantly collapsing wave functions in this vast, cosmic web of entanglement, constantly affecting you and everything around you in subtle, quantum ways. This sounds mystical, but it's not. It's physics. The math is clear. The experiments confirm it. Entanglement is real. Non-local correlations exist, and observation of entangled systems affects the entire entangled state. You are not separate from the universe. You're quantum mechanically woven into its fabric, and light is the loom that constantly weaves you tighter into the pattern. Now, let's talk about something that's going to challenge your sense of time and history even more than what we've already discussed: the quantum eraser experiment. This experiment, variations of which have been performed since the 1980s with increasingly sophisticated setups, demonstrates something that seems impossible. It shows that you can retroactively determine whether a particle behaved as a wave or a particle in the past by making a choice in the present about whether to observe which path information. Here's how it works. In a standard double-slit setup, now extend this to cosmic scales. Light from distant quasars, photons that have been traveling for billions of years, are hitting our telescopes right now. When we observe them, when we choose how to measure them, are we determining which path they took through space billions of years ago? Are we collapsing the history of the universe retroactively? The math of quantum mechanics says yes. Our observations today can determine the definite history of events that happened long before we existed. This is why Wheeler called it the participatory universe. We're not passive observers recording a pre-existing history. We're active participants creating the history through our observations. And the medium of this participation is light. Photons carry information from the past to the present, but their quantum state doesn't become definite, doesn't crystallize into a specific history until we observe them. So does matter exist without light observing it? At this point, I hope you can see that the question is far deeper than it first appeared. Matter, light, and observation are so deeply interconnected in quantum mechanics that trying to separate them is like trying to separate wetness from water. Matter can exist in superposition without observation, but superposition is such a radically different mode of existence from what we normally mean by exist that it barely qualifies as the same thing. Its potential existence, probabilistic existence, ghost-like existence across multiple incompatible states simultaneously. The matter we know, the matter we interact with, the matter that makes up our bodies and the world we experience, only exists in definite form because of constant observation, and that observation is overwhelmingly mediated by light. But before we wrap this up, I want to bring this full circle and make it deeply personal. In the next section, I'm going to connect all of this to your daily life, to your perception of reality, and to why understanding this changes everything about how you should think about existence itself. You've been absorbing abstract physics for a while now. Let's make it concrete. Let's talk about you. Every morning you wake up, you open your eyes, and light floods in. Photons that left the sun 8 minutes ago bounced off your walls, traveled through your window, and now strike your retinas. These photons were in superposition as they traveled, existing as probability waves. But the moment they hit your retina, the moment they're absorbed by rhodopsin molecules in your eye cells, their wave function collapses. They choose a definite energy, a definite position, triggering a definite chemical reaction that becomes a neural signal. You've just collapsed trillions of wave functions. You've taken a universe of possibilities and actualized one specific outcome. You've created, in a very real quantum mechanical sense, the definite reality you're experiencing. Now you look at your hand again, like I asked you to at the beginning. Light is bouncing off it constantly. Photons from ambient lighting hit your skin, scatter, and some reach your eyes. Each scattering event is a measurement, a collapse of the photon's wave function, and a correlation with the quantum state of the atoms in your skin. Your hand is being observed into definite existence, billions of times per second, by this constant rain of photons. Without this continuous observation, without this constant interaction with light, the quantum correlations between the atoms in your hand would start to behave more strangely. Decoherence would slow. Quantum effects would become more pronounced. You are not a static object. You're a dynamic process, a pattern of matter constantly being held in definite form by observation, primarily by light. And it's not just your body. Your thoughts right now, as you process these ideas, are patterns of neural activity. Billions of neurons firing in specific sequences, electrochemical signals cascading through neural networks. These patterns are maintained by constant interaction. Neurotransmitters crossing synapses, ion channels opening and closing, electrical potentials shifting. All of these processes are fundamentally quantum at the microscopic level. The chemical bonds in neurotransmitter molecules, the electron transport chains in your mitochondria producing energy, the quantum tunneling of protons and enzymes, these are all quantum processes. They mostly behave classically because they're in a hot, wet, light-filled environment that causes rapid decoherence. But they're still quantum systems at base. And the definite, specific pattern of neural activity that is you right now is being constantly held in that definite state by continuous interaction and observation. You, as a conscious being, are an emergent pattern arising from quantum systems being constantly observed into classical behavior by their environment. And the deepest question in all of this is consciousness itself simply a pattern of physical processes? Or does consciousness play a special role in observation and wave function collapse? This is the hard problem of consciousness, and quantum mechanics makes it even harder. Some interpretations of quantum mechanics, like von Neumann-Wigner interpretation, suggest that conscious observation is fundamentally different from mere physical interaction. That consciousness is necessary to collapse wave functions, that the universe exists in superposition until a conscious being observes it. Most physicists reject this view as unnecessary and problematic. Decoherence explains the appearance of wave function collapse without requiring consciousness. Physical interaction with the environment is sufficient, but we don't actually know. We don't know if consciousness is special. We don't know if there's something about subjective experience, about qualia, about the feeling of being you, that plays a role in quantum mechanics beyond just being a pattern of atoms. What we do know is that you are an observer. You are constantly collapsing wave functions by interacting with the world. And the primary way you interact with the world is through light. Vision is your dominant sense. The information you gather about reality comes overwhelmingly from photons hitting your eyes. You navigate reality through light. You understand your environment through light. You connect with other humans, reading their expressions and body language through reflected light. You are a light-based observer, collapsing the quantum wave functions of reality into definite, shareable, communicable form. And here's the profound implication. If reality is, in some sense, participatory, if observation helps create the definite universe, then you matter, literally. Your observations, your interactions with the world through light, contribute to the existence of definite reality. Not in some vague, metaphysical sense, in a concrete, quantum mechanical sense. By observing, you are collapsing superpositions. You are choosing from all possible outcomes, which one becomes real in your light cone. Your decisions about what to observe, where to look, what to pay attention to, have quantum mechanical consequences. Now, these consequences are vanishingly small for individual observations. The universe is vast. Most of reality is being observed by physical processes that have nothing to do with you. But you are part of the universe observing itself. You are one node in the vast network of observation and interaction that gives reality its definite character. And if Wheeler is right about delayed choice and participatory observation working backward in time, then your observations today might be affecting the past, determining which of the many possible histories of the universe is the actual history that led to you. This isn't to say you have godlike powers. You can't choose to observe the universe in a way that violates the laws of physics or creates logical contradictions. The wave function contains only physically possible outcomes, and observation selects from those. But within that vast space of possibilities, your observations contribute to determining which possibility becomes actual. You are a creator of reality, a small one, a local one, but a creator nonetheless. And if that doesn't give you a sense of cosmic significance, I don't know what will. Think about how this changes your relationship to the world. You're not a passive observer recording a pre-existing external reality. You're an active participant in an ongoing process of reality creation. The world you see isn't just out there, waiting to be discovered. It comes into definite existence, partially through your act of seeing it. This doesn't mean you can wish things into existence, or that reality is purely subjective. The constraints of physics, the prior states of quantum systems, the web of entanglement connecting everything, all of these limit what's possible. But within those constraints, observation matters, seeing matters. Light carrying information from the world to your eyes matters. And here's the ethical implication that I think is profound. If we are participatory observers, if our interactions with reality through light help create the definite world we inhabit, then we have a responsibility to observe carefully, thoughtfully, and with awareness of the consequences. The attention we pay to things matters. The way we look at the world, the phenomena we choose to study, the aspects of reality we choose to measure and record, all of this contributes to which aspects of the quantum superposition of possibilities become real. This is true scientifically. Our experiments determine which questions get answers. Our observations determine which quantum states collapse and which remain in superposition, unexamined. And it might be true ethically and existentially. The world we create through our collective observation, the reality we bring into definite existence through our attention and interaction, is partially shaped by what we choose to observe. We are, all of us together, weaving reality into existence through our observations, moment by moment, choice by choice. And light is our tool, our thread, our connection to the quantum fabric of the universe. So when I ask, does matter exist without light observing it? I'm really asking, what is your relationship to reality? Are you a passive recorder or an active participant? Do you simply witness a world that would be exactly the same without you? Or do you contribute to the ongoing creation of definite reality? Quantum mechanics, for all its strangeness, gives us an answer. You participate. You matter. You are part of the universe becoming real. And that's not mysticism. That's physics. Now, let me pull back and give you the bigger picture, because we're in the home stretch, and I want to make sure you have a coherent framework for all of this mind-bending information. The classical worldview, the one most of us grew up with, posits a reality that's objective, definite, and independent of observation. Matter exists with specific properties, whether anyone's looking or not. Space and time are a fixed stage on which events play out. The past is determined, the future is open, and the present is a thin slice between them, moving forward inexorably. Quantum mechanics demolishes this picture completely. Not around the edges, not in obscure edge cases, but at the foundation of reality itself. Matter doesn't have definite properties until measurement. Position, momentum, spin, polarization, all of these are indefinite, existing as superpositions of all possibilities until observation forces a choice. Space-time isn't a fixed stage. It's entangled with matter and energy. Observations can affect distant objects instantaneously through entanglement, violating our intuitions about locality. And the distinction between past, present, and future becomes fuzzy when observation can determine past events. The past isn't fixed until observed. The present isn't a thin slice, but an extended event of observation and decoherence. The future isn't separate from the present, but entangled with it through quantum correlations. And light, electromagnetic radiation, photons, are the primary mechanism connecting it all. Light carries information. Light mediates interactions. Light collapses wave functions through decoherence. Light connects observers to the observed. Without light, or more generally, without interaction that could carry information, quantum systems remain in superposition indefinitely. Matter exists in a ghostly, potential form, all possibilities equally real or equally unreal. With light, with observation, superposition collapses. Potentiality becomes actuality. The wave function of possibilities reduces to a single outcome. Matter becomes definite. And this process isn't optional or avoidable. Light is everywhere. Photons pervade the universe. From the cosmic microwave background filling all of space to the visible light from stars to the infrared radiation from warm objects to the radio waves from our technology, electromagnetic radiation is constantly probing, constantly interacting, constantly observing. The universe is constantly observing itself through light. And we, as conscious observers equipped with visual systems that detect and process light, are particularly sophisticated nodes in this self-observation network. Now here's the framework I want you to take away from this. Reality exists at multiple levels. At the deepest quantum level, it's a vast superposition of all possible configurations, described by a wave function evolving according to the Schrödinger equation. This is pure, unobserved reality, potential rather than actual, existing in Hilbert space, not physical space. At the intermediate level of decoherence, environmental interactions, primarily mediated by light, destroy quantum coherence and create the appearance of classical behavior. Systems become entangled with their environments. Their quantum states become correlated with environmental states, and the interference between different possibilities becomes practically unobservable. This is where matter starts to look real in the classical sense. At the top level of conscious observation, intelligent observers like us collect information about these semi-classical systems using light-based senses, primarily vision. We process this information, create models of reality, and make decisions about what to observe next. And our observations, our interactions through light, feed back into the quantum substrate, collapsing wave functions, determining outcomes. These levels aren't separate realms. They're different descriptions of the same underlying reality, each appropriate for different scales and contexts. And threading through all of them is light. Light connects the quantum substrate to the semi-classical world through decoherence. Light connects the semi-classical world to conscious observers through vision. Light carries information up the hierarchy and collapses wave functions down the hierarchy. Light is the linchpin holding reality together. So the answer to our title question, does matter exist without light observing it, is matter exists as quantum superposition without observation, but the matter we know and experience, the definite, classical matter of everyday life, requires observation to exist, and that observation is primarily mediated by light. Matter and light are co-creative. Neither fully exists without the other. Matter provides the quantum substrate, the possibilities. Light provides the observation, the actualization. And we, conscious observers, sit at the intersection, experiencing the actualized world, while simultaneously participating in its actualization through our light-mediated observations. This is the participatory universe. This is reality as an ongoing process rather than a fixed state. This is the quantum mechanical worldview that emerges when you take the mathematics seriously and follow the experimental evidence wherever it leads. Is it weird? Absolutely. Does it violate our intuitions? Completely. Is it true? As far as we can tell with our best experiments and our most rigorous theories, yes. And here's the final thought I want to leave you with. This isn't bad news. This isn't nihilistic or depressing. This is empowering. You're not a meaningless speck in an uncaring universe, passively witnessing a reality that would be exactly the same without you. You're a participatory observer in a quantum universe, contributing to the ongoing creation of definite reality through your interactions mediated by light. Every time you open your eyes, every time photons hit your retinas, you're collapsing wave functions. You're choosing outcomes. You're making reality real. And collectively, as a species of observers, we're weaving the classical reality we inhabit from the quantum possibilities underlying everything. We're creating the world through our attention, our observations, our choices about what to measure and when. This gives meaning to consciousness. This gives significance to observation. This connects us deeply to the physical universe in a way that the classical worldview never could. We're not separate from reality, looking at it from outside. We're embedded in reality, quantum mechanically entangled with it, participating in its ongoing creation. And light is our connection. Light is our tool. Light is how we reach out from our subjective, conscious experience and touch the objective, quantum world, collapsing its possibilities into the definite experiences we share. So the next time you look at anything, really look at it. Remember, you're not just seeing it. You're helping to create its definite existence through the act of observation mediated by light. You're a reality creator. Small scale, local, constrained by physics, but real nonetheless. And that's not mysticism or metaphysics. That's quantum mechanics. That's the universe we actually live in. That's the profound truth that emerges when we ask the seemingly simple question, does matter exist without light observing it? The answer is, matter and light and observation are so deeply intertwined that the question itself reveals a false dichotomy. They're aspects of a unified reality, each incomplete without the others. Matter provides the substance. Light provides the connection. Observation provides the actualization. Together, they create the world we experience. The definite, shareable, classical reality we inhabit emerges from their interaction. And you, right now, are participating in that emergence. You are part of the universe observing itself into definite existence. You are a node in the vast network of observation and interaction that gives reality its character. You matter, literally and figuratively. Your observations contribute to the shape of reality. Your consciousness, processing information carried by light, is part of the cosmic process of actualization. And if that doesn't blow your mind, I don't know what will. Thank you for staying with me on this journey through quantum mechanics and the nature of reality. If this video expanded your understanding of existence itself, hit that like button. Subscribe to the channel for more deep dives into the fundamental nature of reality. And comment with your biggest takeaway, your lingering questions, or your existential crisis. I read every comment, and your thoughts become part of the ongoing conversation about these profound questions. And remember, every time you observe the world through light, you're not just seeing what's there. You're participating in making it there. You're collapsing quantum possibilities into classical actualities. You're creating reality. So observe wisely, observe carefully, and observe with wonder at the profound strangeness and beauty of the universe we're all weaving into existence together, one photon at a time. Now, let's venture even deeper into territory that will fundamentally reshape how you understand your place in the cosmos. Because there's a dimension to this observer-matter-light relationship that we haven't fully explored yet, and it's going to tie together everything we've discussed into a framework that's both terrifying and exhilarating. I want to talk about the measurement problem in its most radical form, and why some of the greatest minds in physics have concluded that consciousness might not just be along for the ride in this quantum universe. It might be driving the car. The measurement problem, at its core, is this: the Schrödinger equation, the fundamental equation of quantum mechanics, describes a completely deterministic, reversible evolution of the wave function. Given the wave function at one time, you can calculate it at any other time, forward or backward. Nothing in the equation says anything about collapse. Nothing in the fundamental mathematics of quantum mechanics explains why superpositions ever resolve into definite outcomes. Yet they do, every time. When you measure a quantum system, you get a definite result. The wave function appears to collapse from a superposition of many possibilities into one actuality. This is bizarre. The equations don't predict it. It's something we add by hand, an extra postulate. And then, when a measurement happens, the wave function collapses. But what counts as a measurement? What's the physical mechanism? At what exact moment does it happen? These questions have haunted quantum mechanics since its inception in the 1920s, and we still don't have definitive answers. Eugene Wigner, a Nobel Prize-winning physicist, proposed something radical in the 1960s. He argued that consciousness is what causes wave function collapse. Not just any physical interaction, but the moment when information enters conscious awareness. Here's his reasoning. If you have a quantum system in superposition, and you measure it with a detector that's also a quantum system, then you just create a larger superposition. The system and the detector become entangled, existing in a superposition of system in state, and detector reads A, plus system in state B, and detector reads B. You haven't solved the measurement problem. You've just made it bigger. You could say the laboratory itself, the environment, all of these cause decoherence, and that's what creates the appearance of collapse. But decoherence, mathematically, doesn't actually reduce the wave function to a single outcome. It just makes the different branches of the superposition unable to interfere with each other. The superposition still exists in the math. All possibilities are still there. They're just isolated from each other. So when does the superposition actually become one definite reality? Wigner argued, when a conscious observer becomes aware of the result. Only consciousness, standing somehow outside the quantum mechanical description, can actualize one outcome from the many possibilities. This is the von Neumann-Wigner interpretation, and most physicists hate it. It seems to give consciousness special physical status, which feels unscientific. It suggests dualism, that consciousness is somehow separate from physical processes. And it raises impossible questions. Do bacteria have enough consciousness to collapse wave functions? What about AI? Where's the threshold? But here's the thing. No one has definitively refuted it. We've created alternative interpretations, like many worlds and pilot wave theory, precisely to avoid giving consciousness a special role. But we haven't proven consciousness isn't special. We've just found ways to avoid the question. And there are experiments that hint, just hint, that consciousness might be relevant to quantum mechanics in ways we don't understand. In the 1970s and 80s, the Princeton Engineering Anomalies Research Laboratory, run by Robert John and Brenda Dunn, conducted millions of trials, examining whether human intention could influence random number generators based on quantum processes. They claimed to find tiny but statistically significant effects. The research was controversial, and most scientists rejected it, but it was never definitively debunked. The lab closed in 2007, but similar research continues at places like the Institute of Noetic Sciences. I'm not saying these experiments prove consciousness affects quantum mechanics. The effects are tiny, right at the edge of statistical detectability, and there are legitimate methodological concerns. But the fact that we can't just dismiss the question outright, the fact that rigorous researchers can even ask whether consciousness influences quantum outcomes, tells you how open the question really is. Now, let me take this in a different direction that's going to connect everything back to light in a way you haven't considered. What if consciousness evolved, specifically because it provides an efficient way to collapse wave functions? What if being conscious, having subjective experience, is nature's solution to the measurement problem at biological scales? Think about it this way. Every organism needs to interact with its environment to survive. It needs to extract information about the world, process that information, and make decisions. At the quantum level, every interaction involves entanglement. An organism that wasn't conscious, that was just a classical information processing machine, would become increasingly entangled with its environment, existing in vast superpositions of all possible interactions. But consciousness might provide a mechanism for definite experience, for actualizing one specific world line from the many possibilities. By being conscious, by having subjective experiences that are definitely this rather than that, organisms might be automatically collapsing wave functions locally, maintaining themselves as definite classical objects in a quantum universe. And how does consciousness primarily interact with the environment? Through light. Vision evolved because light carries information about the environment efficiently. Photons travel at the speed of light. They're not affected by most interactions with matter, except at the surface, and they carry information about color, intensity, and source. An organism with vision can collapse wave functions at a distance. It can observe objects without touching them, collapsing their quantum states by having photons scatter off them and into detector cells. Vision is long-range wave function collapse mediated by light. So maybe consciousness and vision co-evolved precisely because they provide an efficient mechanism for organisms to maintain definite, classical existence in a quantum universe. Consciousness collapses local wave functions to create definite subjective experience. Vision extends this collapse to distant objects through light-mediated observation. You're not just a pattern of atoms that happens to be conscious. You might be conscious because being conscious is how biological systems solve the measurement problem. And you have eyes that detect light because light is the universe's information carrier, the mechanism by which observation actualizes distant reality. This is speculation, I'll admit. This is frontier territory, where physics meets biology, meets philosophy of mind. But it's not arbitrary speculation. It's following the logic of quantum mechanics into domains where it makes testable predictions about the relationship between observation, consciousness, and the physical world. And whether or not consciousness is special, whether or not it plays a unique role in collapsing wave functions, one thing is absolutely certain. You experience a definite world. Your conscious experience is not of superposition. You don't perceive quantum uncertainty. You experience one specific outcome, moment by moment, a definite trajectory through the space of quantum possibilities. Something is selecting, for your experience, one outcome from the many quantum mechanical possibilities. Whether that selection is caused by your consciousness or happens before information reaches your consciousness through decoherence, the selection happens. Reality becomes definite in your experience. And that definite reality is overwhelmingly mediated by light. The world you experience consciously is primarily the world illuminated and revealed by electromagnetic radiation interacting with your visual system. You live in a light-created world, not metaphorically, literally, the definite, conscious experience you have of reality is constructed from information carried by photons from your environment to your retinas, processed by your brain, and presented to your consciousness as the world. Without light, you'd be blind, obviously. But more than that, without light, the world around you would decohere much more slowly. Quantum effects would persist longer. The boundary between quantum and classical would be blurrier. Reality itself would be less definite. Light makes the world real, both in the quantum mechanical sense of causing decoherence and wave function collapse, and in the experiential sense of providing the information that becomes your conscious perception of reality. Now I want to address something that might be bothering you. Doesn't all this talk about observation creating reality sound like idealism? The philosophical position that reality is fundamentally mental, that matter is derivative of mind? It's not. At least, it doesn't have to be. What quantum mechanics is telling us isn't that reality is mental, but that reality is relational. Properties of systems aren't absolute. They're defined in relationship to other systems, particularly through interaction and observation. An electron doesn't have a definite position as an absolute property. It has a definite position relative to another system that has interacted with it in such a way as to establish that relation. The position is real, but it's real as a relationship, not as an intrinsic property. This is called relational quantum mechanics, developed by Carlo Rovelli in the 1990s. In this view, the wave function isn't describing the absolute state of a system. It's describing the state of a system relative to an observer. Different observers can have different wave functions for the same system, and that's fine, because the wave function is about the relationship between observer and system, not about the absolute state of the system. Matter exists without observation in this view, but it doesn't have definite relational properties until observed. Its properties are potential until actualized through interaction. And light, once again, is the primary interaction mechanism. Light mediates the relationships between systems. Light carries information that establishes correlations. Light creates the web of relationships that is physical reality. You, as an observer, exist in a web of light-mediated relationships with the rest of the universe. The definite properties the world has, relative to you, are established through photons traveling from objects to your eyes, creating quantum correlations between your visual system and the external world. This isn't idealism. This isn't saying mind creates matter. This is saying relationships create definite properties, and light creates relationships. Let me give you one more mind-bending implication of all this, something about the arrow of time that's going to make you question your entire experience of past and future. Time, in fundamental physics, is largely symmetric. The equations of quantum mechanics work the same forward and backward in time. There's no fundamental arrow pointing from past to future. Yet we experience time as flowing in one direction. We remember the past, but not the future. We see effects following causes, never the reverse. Where does this asymmetry come from? The standard answer is entropy, the second law of thermodynamics. Entropy increases over time, giving time a direction. But why does entropy increase? Because the universe started in a low entropy state at the Big Bang, and it's been evolving toward higher entropy ever since. But here's where it gets weird with quantum mechanics and observation. Entropy is related to information. High entropy means less information, more uncertainty. Low entropy means more information, more order. And information, in quantum mechanics, is created by measurement. Before measurement, a quantum system has less information, more entropy, because it's in a superposition of many possibilities. After measurement, it has more information, less entropy, because it's been collapsed to a definite state. So measurement, observation, creates information and temporarily decreases local entropy. And measurement is primarily mediated by light, by photons interacting with systems. Here's the implication. The arrow of time might be related to the directionality of observation. We observe from past to future because observations create information, and information accumulation defines the direction from past to future. It's not that time flows and we observe it flowing. It's that our observations create the flow of time by generating information, by collapsing wave functions, by actualizing definite outcomes from quantum possibilities. And light is the mechanism. Photons travel from sources to observers, carrying information, collapsing wave functions, creating definite events that become the past. The universe's history is being written by light observing matter, moment by moment, collapsing quantum possibilities into classical actualities that become fixed in the past. This is the block universe meets quantum mechanics meets thermodynamics. The past is definite because it's been observed, information has been created, wave functions have collapsed. The future is indefinite because it hasn't been observed yet. It still exists as quantum superposition of possibilities. And the present, the now you're experiencing, is the moving boundary where light is constantly observing matter, constantly collapsing wave functions, constantly writing the definite classical past from the quantum possible futures. You're not just experiencing time flow, you're participating in creating that flow through your observations mediated by light. Every moment, photons are hitting your eyes, collapsing quantum states, generating information, creating definite events that instantly become part of the fixed past. The world crystallizes into history through your observations. And if this is true, if observation through light really does create the past from quantum possibilities, then the history of the universe is being written backward from the present. Observers existing now are collapsing wave functions that determine what happened billions of years ago. The Wheeler delayed choice experiments suggest exactly this. The photons from distant quasars didn't have definite paths through space until we observed them. The universe didn't have a single definite history until observers emerged to collapse its quantum state. All possible histories existed in superposition, and our observations are selecting which history is the actual history, retroactively, back to the Big Bang. This seems impossible. This seems to violate causality. How can the present determine the past? But in quantum mechanics, causality is more subtle than classical intuition suggests. The past wasn't definite until observed. It existed as quantum possibility. Observation doesn't change a fixed past. It actualizes an indefinite past. And this actually resolves some deep puzzles about cosmology. Why is the universe fine-tuned for life? Maybe because only universes fine-tuned for life can have observers to collapse their wave functions retroactively. The universe that exists is the one compatible with observers existing to observe it. Why do we appear to live in a low-entropy early state with an arrow of time pointing toward increasing entropy? Maybe because only such universes can have observers who experience time directionally, and only universes with such observers have definite histories. The anthropic principle becomes concrete and quantum mechanical. Observers don't just happen to find themselves in a universe compatible with their existence. Observers retroactively create the universe compatible with their existence by collapsing its quantum state. And light is the mechanism of this retrocization. Photons traveling from the past to the present carry quantum information in superposition. When we observe them, when they hit our eyes or our detectors, we collapse their wave function, determining retroactively which path they took, which history they came from. We're not just living in a participatory universe. We're living in a self-creating universe, where the present creates the past through observation mediated by light, and that past creates the conditions for the present to exist and observe. It's a causal loop, but a consistent one. The universe bootstraps itself into existence through the quantum mechanical connection between observers and the observed across time. Now, I want to bring this to a deeply personal level, because understanding this changes not just how you think about physics, but how you think about your own existence and significance. You are a pattern of matter that has become complex enough to observe itself and the universe. You're made of atoms that were forged in stars, ejected in supernova, condensed into planets, organized into molecules, and evolved into living systems capable of consciousness. Every atom in your body has a history stretching back billions of years. But that history wasn't definite until it was observed. The path your atoms took through space and time, the reactions they underwent, the organizations they formed, all of this existed in quantum superposition until observation collapsed it into one definite history. Some of those observations were natural physical processes. Photons from stars interacting with atoms, collapsing their positions. Environmental decoherence, causing density fluctuations to become definite structures. The universe observing itself through light. But some of those observations are happening right now, through you. When you look at the stars, when light from distant suns enters your eyes, you're collapsing quantum states that determine the definite history of photons that left those stars years or centuries ago. You're not just seeing the past. You're helping to create the definite past by observing it. And this means your existence matters in a profound physical way. You're not an accidental byproduct of a universe that would be exactly the same without you. You're a participant in creating the definite reality of that universe. Your observations contribute to the cosmic process of actualization. The universe becomes real, becomes definite, through observers like you, making measurements, collapsing wave functions, forcing quantum possibilities to choose specific actualities. And light is your tool, your connection to the universe. Through vision, through observing light that has traveled from distant sources, you reach across space and time to collapse wave functions, to create definite reality. You are not separate from the universe. You are the universe observing itself, knowing itself, creating itself through observation. This is the participatory anthropic principle at its most profound. And it's not mysticism. It's following the mathematics of quantum mechanics to its logical conclusions about the relationship between observers and reality. Does it mean you're all-powerful, that you can create any reality you want? No. The wave function, the quantum state of the universe, constrains what's possible. You can only collapse outcomes that are permitted by the quantum state, by the laws of physics, by the prior history. But within those constraints, observation matters. Choosing what to observe, how to observe it, which aspects of reality to pay attention to. All of this influences which of the many possible outcomes becomes actual. Collectively, as a species of observers, we're weaving reality from quantum possibilities. The world we create depends on what we choose to observe, what we choose to study, what we choose to measure. This gives profound meaning to the scientific enterprise. Science isn't just discovering a pre-existing reality. Science is participating in creating definite reality by making careful, controlled observations and measurements. Every experiment that measures a quantum property collapses that property from superposition to a definite value. Every telescope that observes distant galaxies collapses the quantum state of photons traveling for billions of years. Every detector that measures a particle collapses wave functions that might determine events in the deep past. We are creating the definite universe through our observations, mediated overwhelmingly by light. And this brings us full circle to our original question. Does matter exist without light observing it? The answer, after this deep dive into quantum mechanics, consciousness, observation, and the nature of reality itself, is complex and profound. Matter exists as quantum superposition without observation, a ghostly realm of all possibilities simultaneously real and unreal. Light, interacting with matter, collapses these possibilities into definite states through decoherence and measurement. Observers, particularly conscious observers, experience the definite classical reality created by this constant observation. The matter we know, the matter we can talk about, the matter that makes up our bodies and our world, exists because light observes it. And we, as conscious observers, participate in this process.